Hello everyone. Today I will be talking about Joseph Fourier, who was a very important French mathematician in the 1700s. So I'm going to begin by talking a little bit about his life and growing up. So he was born in France in 1768 and was the son of a tailor. He was orphaned by the early age of 9, and he was educated by the Benedictine order of the convent of St. Mark, which he was trained in mathematics and military engineering. He then accepted a military lectureship on mathematics and took a prominent part in promoting the French Revolution in his region. So he then got caught up in the politics of the French Revolution. He was a revolutionary, but other revolutionaries actually jailed him when he came to the defense of victims during the Reign of Terror. Fourier accompanied Napoleon Bonaparte on his Egyptian expedition in 1798 as a scientific advisor, and he actually made him the secretary of the newly found Institute of Egypt. He did many types of negotiations and administration work during this campaign in Egypt. So while he was there, he began to think about heat flow. He was motivated to work with astonishing energy and built roads, engineered a large land drainage program, and wrote papers on mechanics and a book on Egypt. So while he was in France, this was around 1804, he submitted a paper on the analytical theory of heat to the Academy of Science. So this inevitably offended many of the mathematicians, and he fought for 15 years to even get it published. He showed how to describe heat flow in solid bodies, but it most importantly created a form of mathematics that led to engineers and scientists being able to solve any kind of problem that before would have been quite impossible. So in many ways, this paper broke the rules in their minds. So the adventure in Egypt really did shape Fourier and helped fuel a lifelong obsession with heat and with the healing power of it. So what exactly did he discover? In 1820, which is also around the time that his health started to deteriorate, more on that later, he made his discovery of calculating that an object the size of the Earth and at its distance from the sun should be colder than the planet actually is if it's warmed by only the effects of incoming solar radiation. So Fourier noted that the actual mechanisms that determine the temperatures of the atmosphere included convection, which was not present in this experimental device. So a few fun facts about his discovery and often overlooked facts. He was the first to propose that the Earth's atmosphere acts to raise the planet's temperature, and applied his mathematical skills to an aspect of natural science, which was the greenhouse effect. So he discovered this effect by explaining and comparing the Earth with its covering of air to a box with a glass cover. So this was a pretty well-known experiment, but here's how it works. The box's interior warmed up when the sunlight entered, so the heat could not escape. So Fourier knew that the main effect of the glass was to keep the air from wafting away. This is how the greenhouse effect eventually came to be. So one question that he often asked himself was, why doesn't the planet keep heating up as it receives sunlight? Since he knew that heated surfaces emit thermal energy, Fourier then reasoned that the Earth would emit radiation that was absorbed by the sun back into space. So his answer to these questions was the greenhouse gas effect. He affected the understanding of climate change, with scientists asking questions about this effect, even years after his death, and the impact of his answer is still being debated and is quite a hot topic nowadays. So a few quotes that kind of help better understand his reasoning and where he came from. His first quote was, quote unquote, mathematics compares the most diverse phenomena and discovers the secret analogies that unite them. Another one, the profound study of nature is the most fertile source of mathematical discovery. Mathematical analysis is as extensive as nature itself. It defines all perceptible relations, measures times, spaces, forces, temperatures. This difficult science is formed slowly, but it preserves every principle which it has won acquired. It grows and strengthens itself incessantly in the midst of the many variations and errors of the human mind. Its chief attribute is clearness. It has no marks to express confused notations. It brings together the phenomena, the most diverse, and discovers the hidden analogies which unite them. So a few more. There cannot be a language more universal and more simple, more free from errors and obscurities, more worthy to express the invariable relations of all natural things than mathematics. It interprets all phenomena by the same language, as if to attest the unity and simplicity of the plan of the universe, and to make still more evident that unchanging order which presides over all natural causes. And the last quote that I will mention here: the effects of heat are subject to constant laws, which cannot be discovered without the aid of mathematical analysis. The object of the theory is to demonstrate these laws. It reduces all physical research on the propagation of heat to problems of the integral calculus, whose elements are given by experiment. No subject has more extensive relations with the progress of industry and the natural sciences, for the action of heat is always present. It influences the processes of the arts and occurs in all the phenomena of the universe. Those are a few super interesting quotes about his view of mathematics. So in 1830, Fourier died from a chronic illness that he actually contracted in Egypt, and by the time of his death on May 16th, his work permanently expanded the character of engineering itself. He was extremely important in discoveries in the field of mathematics and physics. Thank you so much for watching. Hope you enjoyed.